Everyone keeps telling you that you need NVIDIA to run AI locally. But what if that is only half the truth, and you are overpaying for power you do not actually need? In 2026, the real question is not just what is the fastest GPU, it is which GPU actually fits your workflow, your budget, and the type of AI systems you want to run. Today, we are breaking down the top 3 GPUs from 3 different companies so you can see exactly how they compare and where each one actually makes sense. We are looking at the NVIDIA GeForce RTX 4090, the AMD Radeon RX 7900 XTX, and the Intel Arc B580. And each one represents a completely different level of performance and a completely different ecosystem. Starting with NVIDIA. The GeForce RTX 4090 is still the gold standard for local AI workloads, and the main reason is not just raw performance, it is the ecosystem that surrounds it. You get 24 GB of GDDR6X VRAM, which is enough to run large language models locally, including optimized and quantized models at higher parameter ranges. It has over 16,000 CUDA cores, which means massive parallel compute and over 80 teraflops of performance, making it one of the most powerful consumer GPUs available. On top of that, you are getting over 1,000 gigabytes per second of memory bandwidth, which is critical when moving large tensors during inference or training. But the real advantage here is CUDA. Almost every major AI framework like PyTorch and TensorFlow is optimized for CUDA, which means tools like local LLM runners, diffusion pipelines, and agent frameworks work out of the box with minimal setup. This is why NVIDIA continues to dominate. Everything is optimized for it. Everything just works. The downside is cost and ecosystem lock-in, because once you are in CUDA, you are staying there. Now moving to AMD. The Radeon RX 7900 XTX is where things start to shift. On paper, this card is extremely competitive. You are getting the same 24 GB of VRAM as the 4090, which is one of the most important specs for AI workloads. It delivers strong compute performance and very high memory bandwidth, so in terms of raw numbers, it is not that far behind. The difference comes down to the software stack. Instead of CUDA, AMD uses ROCm, which is their open compute platform. This gives you more flexibility and often better value per dollar, but it also introduces some friction. Some AI tools require extra setup, and some are not fully optimized yet. That said, ROCm has been improving quickly, and more frameworks are starting to support it directly, which makes AMD a strong option if you are willing to trade convenience for cost efficiency. Finally, we have Intel. The Arc B580 is your entry point into running AI locally without spending a massive amount of money. This card comes with 12 GB of VRAM, which is enough for smaller models, lightweight inference, and experimentation with local pipelines. It delivers solid entry-level performance and decent memory bandwidth, but it is not trying to compete with high-end GPUs. The real advantage here is accessibility. At around $250, this becomes one of the most affordable ways to get started with dedicated AI hardware. Intel uses one API instead of CUDA or ROCm, and while it is still developing, it is improving with each generation. This makes it a great choice for beginners, students, or developers who want to explore AI without committing to a high-end build. You will not be running massive models, but you can absolutely build real workflows and understand how everything connects. So what does this actually mean when choosing the right GPU? If you want maximum performance, the smoothest experience, and full compatibility with modern AI tools, then NVIDIA is still the dominant choice. If you want strong performance with the same VRAM at a lower price, and you are comfortable dealing with some setup and optimization, then AMD is a powerful alternative. And if you are just getting started or you want a budget-friendly way to learn and experiment, then Intel provides a surprisingly capable entry point. The bigger picture is that the AI hardware space is no longer controlled by a single company. NVIDIA may still lead, but AMD is closing the gap, and Intel is opening the door for more developers. That means more competition, better pricing, and faster innovation. The best GPU for AI is not just about raw power, it is about choosing the right balance between performance, cost, and ecosystem. Local AI is becoming more accessible, more customizable, and more personal. Your hardware choices directly impact what you can build and how far you can push your systems. Whether you are running local language models, building agents, or experimenting with new pipelines, understanding these differences gives you a real advantage. Thanks for watching FrontEnd Systems Lab. Please subscribe for more under-the-hood content.